Hey guys, welcome to my long requested in-depth synesthesia tutorial. I recently created this shader and published a video on my Instagram that got a lot of positive feedback and also many requests on making a tutorial on how I created this effect. And since this is a quite cool looking but also not overly complicated shader, I thought this would be a great starting point on teaching you guys on how to make super cool looking audiovisual effects with synesthesia. So grab a cup of coffee. This is probably going to take a while since we want to make this hands-on, recreating the whole effect from scratch. You can follow along the whole video, and you can also go on my Patreon page where I will publish the whole finished scene, and you can also download it from there, so either way is fine. I also want to remind you to like and subscribe to my channel. This always helps me to grow and get motivation to make more free content for you guys. But yeah, let's start with this. If you haven't made a synesthesia scene before, it's actually super easy. You just go to this page with the scenes and then create a new scene. And it will start with this and some scene infos on the right. Here you can set some a title, some description and a thumbnail. And then also the most important things, the UI, the controls we want to create to manipulate our scene. Yeah, let's start on. You also need to open the shader editor, which is down here on the left side. And you see that we got a very basic effect here. So to outline the basic idea for this shader, we are going to create a very simple particle system. So first of all, we are going to draw a bunch of circuits at random positions with a random radius, and then moving them in random directions and also looping everything. So we are going to have a continuous motion. Then we are going to apply some feedback. So we are going to see the motion trail of the movement. And then we are also going to modulate a bunch of parameters like the radius and the path of the particles, and for this also using some of the audio uniforms that synesthesia is providing. So we are going to have some visualizations of the music in real time. But first of all, we want to change the UVs here to a center base UV, and with synesthesia you already get the UVC, which is a center-based UV coordinates. So have the origin in the center of the image, so 0, 0 is in the center, and then you have minus to the left and plus to the right, and minus y to the bottom and plus y to the top, and it's also normalized to the minus 0.5 to plus 0.5 range. So this is optimal for creating and painting stuff on the screen. So we do this. Also delete this quickly. Let's define a color variable, initialize it to 0, and then output it here. So we're going to have a black screen. By the way, you can always hit I think on the Mac is Command Enter. I think on Windows is probably Alt Enter to save and live update the scene. So this is always handy. Otherwise you can also hit save here. I think it will do the same effect. You also have some editor settings here where you can change probably the auto compile. You can also set it to change, so every time you change it then it will auto compile, but I think it's more handy to have it on a controlled keyboard command. Because sometimes you get errors, and if you have errors, then it's also resetting some of your controls, so this is something to keep in mind. If you have errors, you have this console output here on the lower right. You can put it up and it will show errors and also mark the errors here in the editor, so you see where the error is happening. Yeah, this is just something to know about if you haven't used the editor before. Okay, now back to the scene. We want to create some rings, so I will add to the color a function call and pass it the UVs. Call it rings for now. We have to define this function also. This function is going to return a vec3 because we want to return the color in RGB, and receives a 2D pointer of the current UV coordinates. And also here we want to initialize a color, so I just copy and paste this color attribute. And then first of all we want to paint a circle, and if you watched my previous tutorial you've probably seen how to do this. It is quite simple. You just want to calculate the distance to the circle and then paint the color at the specific distance from both sides, so we get a ring. So we get a distance value for the circle. The distance to a circle is just simple Pythagoras, so length from the origin of our current coordinate, and then subtract a radius. Let's call the radius, why not? And maybe it would be wise also to change the radius with a control. So for that we add a control here. Call it radius. Add it to ours. Arrange my parameters in groups, so I use base usually for everything that is basic, but maybe for this I use shape because it's affecting the shape to keep my group naming scheme. And you can add some descriptions if you want. You can add a type. You have many different types. Sliders, up-down slider. You also have knobs and toggles and more complex things like colors and drop downs and so on. For now I will stay with the slider and set it to a default of 0.1 to 0.2, that's okay, and arranged, maybe don't allow it to go to 0, but have something like 0.5 as a minimum. Okay, and if you save that, you get an error because we are not returning anything here. So let's finish the function. We want to add our color, and to make a definition of the circle out of the distance we calculated, we can use a smooth step. And what I wanted to do, yeah, go from start with 0 and a small distance to have the outline of the circle smooth. So if you just have a normal step functions come from 0 to 1, you will get a very sharp edge, and you don't want that because then you get an aliasing artifacts and doesn't look good. So we want to have a very small number here, like 0.1, and then use the distance here. So this should give us a filled circle, and also have to return the color. Still get an error because rings UV. It's called rings ring. Yeah, let's call it ring for now, and then have a rings function that does creates the particle system with multiple rings. Also maybe change this to a float for now, because we're just interested in the black and white value and not a color yet. And let's just return this directly. Okay, now this should work, and we get something that looks like inverted Japanese flag. We see that we measure the distance in the way that everything we return 1 if we are outside of the circle and 0 if we are inside the circle. So we want to change that, and we can do this by just inverting it or subtracting it from 1, and then we get a white circle in the center. So the next thing we want to do, first of all, I want to show you a little trick to have the circle always have a sharp edge without aliasing. So it's a trick where we use not have an arbitrary small number, but actually use the derivative of the computation in the CPU, so we get actually the actual pixel size. And there's a function in GLSL that's called fWidth, and we can use this in the X and the Y domain. I'm not 100% sure if that's actually the super correct way, but that usually is the way I'm using it, and that looks fine for me. So this will always give you a sharp looking edge without having any aliasing artifacts going on. But of course you can also have, if you want to have a very smooth edge, you can increase the value here, and then you get something like this. But for now I go with the sharp edge. And also we want a ring, or just the outline of the circle, not a solid or filled circle. So we can use the abstract trick, where we use the absolute and subtract a small number. This is giving us this kind of onion shell of the distance function. And we want to make this a parameter also of our ring. No, actually we don't actually need that. We can just define it here. Float, how did I call it? Thickness. and initialize it to 0.1. Let's see how this looks. This is way too much. 0.01, yeah, something like this is good. We can also later make this a parameter. Oh, let's do it right now. Thickness. Let's make this. Let's leave it the slider as well. 0.1 to 0. Can delete it, and you see parameters that are controls are automatically green, so you know they exist as defined variables already. You don't have to define them. And I want to make it as such that I want to scale it down anyway, so we have a bigger range. I always try to keep the parameters in a 0 to 1 normal range. The controls in the 0 to 1 range, and then scale the parameters inside the code accordingly. So let's give it a 0.5 to have a different range, or even 0.2, so we can have, so this is the smallest, and the thickest is going to be thicker. If you scroll down, you see the scene controls also here in your code editor. So you can change the radius. Also see the max radius is 1, and we want to have the max radius at 2.5, so we have to change this as well. And the thickness you can change also accordingly. So this is great already. Just want to change the radius by 0.5. You can also switch to this view, where you have also the scene controls. Yeah, so let's stay with something like this. Okay, this looks great already. So now, next step is to create a particle system, a very simple particle system, create multiple instances of the ring and move them in different directions. And we also want to have two things. We want to have a random direction of the movement and a random speed. And yeah, then move them accordingly. So I create another function called rings, which is the particles. You can call it ring particles, a bit more obvious. And also change this here, ring particles, and we want to define the number of particles. Int n, let's say 10 for now. We can also change this with a parameter later, but for now let's do this. And we want to have a for loop to iterate over our particles. Also define a color here before, so we can accumulate our particle instances here. And we have a for loop, start with 0, and go up to n, and increase our index in each iteration. Okay, so now we first want to add a ring here. I called it P0 because P0 is a variable we yet have to define, which is going to be our random position. And to create random values, in Synesthesia we have a lot of functions already defined that you can use, and you can go to the Synesthesia docs, and you will have all the functions here. Yeah, you can see this on the website also. Which functions are available, and the functions we want to use to create a random 2D value is hash 21. No, 21. Yeah. So hash 21. If you start typing, you already see all the functions defined. 21 says it's going to be a hash function. All the synesthesia function, by the way, start with the underscore. Hash 21 is taking a single floating point and outputs a 2D floating point, a 2D vector. And we want to input our variable I as a seed for the hash function, and then also center the output 2.5, because the output is going to be in the 0 to 1 range, and we want to have it centered, so the 0 is always in the middle. And let's see how this looks like. We get an error because, yeah, this was of course wrong. We have to put this here to our P0. And add the ring here. And of course it wants us to return the color as well. And this is still giving us an error. Type is not matching. Needs to be a vec3, because in the end we want to create some colors here, so I will return a vec3 for RGB color. And this is not giving us anything. Let's see, of course, yeah, I made an error here. So P0 is the center of the circle, but of course the function needs to know our current coordinate we are testing. So to do that, we have to subtract our vector P, or subtract the center. Let's call this center from our P value. So center minus, the other way around, sorry, P minus the center. So we want to offset or move the point to the random origin we created here, the random center. So this looks already cool. And you can see I have already some mirroring activated, and I want to turn this off for now. And yeah, And if you want to change the random seed value, you can also multiply this here by another number. I think I used 32 for now in my original code. Yeah, so this is great already. The next thing we want to do is also create a random direction. So we want to copy paste this and call it dir for direction, and also give it another initialization, another seed value to have it different than the center coordinates. Okay, so next we want to move the particles along a path, and so we're going to create a variable path. It's going to be a floating point, a float path, and the path for now is going to be linear and is because we want to animate it, we need a time value, so we can use time here. And let's do that. Let's first see how this looks like. And we want to add to our center. So we want to move the points. So we start at the center and then move them in the direction along the path. So we have to add direction times path. And let's see how this looks like. And you see it looks great already. They are moving with in different directions, but they're moving outside the screen because the time value is always increasing to infinity. So at some point they will be outside of the screen, and then you will have a black screen and they will not come back because they will move forever through the universe of the virtual screen. To avoid that, we want to keep having them reappearing in the center all the time, or in the origin where they started. So to do that, we can use a mod. So modular, so every time it goes below a certain value, it will snap back to the beginning. So it's basically like a sawtooth function, triangle function. So it's always starting at 0 and going up to a certain value and then goes down to 0. And the value we're going to use here, let's see, 1 works. Okay, so this is like every second it's starting again at the center. Okay, next we want to also not move them all, not have them looping at the same time, but loop them at different times. So we want to have a loop offset for each particle, and to do that we create another random value and call it offset, time offset, and use a hash function again. This time we want to have a one-dimensional hash function, so just one single floating point. So it's hash 1 1, and put our index as a seed, multiply it by, let's say, 42, why not? And then we are going to add this value here to our time offset. So now it more looks like a particle system, because the circles are appearing at different times and looping in different loops, so it looks more continuous motion. I also want to increase the length of each loop to, let's say, 2. Now we want to change the timing, also make it faster and slower. For that we have to create another control variable here, and we can use the modifier time, no, speed, I think, speed. now we use the slider and modifier speed. Exactly. So this will give us a time variable where you can control the speed. And I always like to have my speed going in positive and negative direction, so I can go back and forth. So if I go to the negative, it's going to be reversed. And let's make the default 0.5. And let's say 0.3. We can later on scale it accordingly. And then we can use speed here. I have to rename it speed also. Speed. Okay, and maybe increase it by 2. Let's see how this looks like. So you can also go back, and now we can also change the number of particles to something bigger. Let's say 30. Okay, so now we actually really have a particle system. And the next thing is to create some feedback, so we have some more cool looking effect. So the feedback will cause a trail of the particles, and to create a feedback we can use a texture variable that stores the last render of the output, which Synesthesia luckily provides for us. So first of all, I want to extract this code into its own function, so we can use it later and combine it with the previous value. So I call this render main image, and here we're gonna use like 4 this time, render main image. And mix it with a feedback value. I want the range to be between 0.5 and 0.99. And our feedback is going to be our parameter, which we have to declare here. Create a new parameter, feedback. By the way, I want to assign this also to a group. And feedback also to group base. And I want to use a knob between 0 and 1 is okay. Default at 0.5 maybe. Let's see. Of course we want to return the color here. Oops. Return color. And now we have to use the feedback. So for this, okay, so we're going to mix the color with the previous color. So color, so previous color, let's call it back for previous pref color. We can use the texture which Synesthesia stores in the variable syn final pass. And we need our UVs also. Let's define them as a variable. UV, we can use this time, we don't use the center one, but just the normal 0 to 1 range, because that's what the texture function expects. And then we want to mix this color based on our feedback control. So previous color, feedback. So this says the higher this value, the higher the feedback value is, the more of the final mix is going to be the previous color. Otherwise, we will add in the new one. So we gonna use mainly our previous color and add a little bit of our current frame to combine them both. And let's see how this looks like. You already see that you get some kind of motion blur. And now if we increase this value, we see we have a feedback option here. You will get some styling trails. And you already see that the trails are very, very dim. And I want to make them a little bit brighter. So I created another feedback control. Call it feedback 2. Assign it to the base group as well. Give it a knob. And this one is going to create the brightness, and we want to increase the brightness by just a tiny amount. To do that, I will make a float brightness. Call it feedback brightness. Let's call it feedback brightness here also. Feedback brightness. And feedback I'm using an underscore name here to not have it confused with the control, because I want to modify it slightly. We want to use 1 and then add a small value of times the feedback control. Without the underscore. And then multiply this with our previous color. And let's see how this looks like. Okay, I think I'm gonna make them both sliders. And put them in its own group. Let's do this quickly. Feedback. And create a group feedback. Sign it also. And here as well. Okay, this has the advantage that we can see the the values next to each other, which is better for control, because with this effect you need to really fine-tune to get just the right amount to not have it fully white. So something like this is cool. Okay. So the next thing we want to do with this effect is to modulate the size of the circle also, to have it growing and shrinking. And for this I used another hash value, called it M for modulate, and it's also just a one-dimensional value, and also give it another random seed here, and then use this as the radius, and we added the radius here already, so I think we need to do it like this, have it as a parameter, and then put in here our max radius, the one which we get as a control, times the mod. Let's see how this looks like. So now we have different colors for each circle. But we want to change them over time with the sine function. So we're gonna use underscore sign, exactly, which is going to be a sign that is going from 0 to 1. Usually it's going from minus 0.5 to plus 0.5, from minus 1 to plus 1. We want to have from 0 to 1, and use our speed value here times the modulated offset. Let's see how this looks like. It's already looking great, but I think first of all, this by 0.5, and I think we want to make it faster also. Let's see. Probably even faster, probably quite a bit more amplitude here, say 10, yeah, something like this. Yeah, I think this looks good. And maybe now is also a good time to add some color. And for the color, for now, I'm going to use a simple color palette function, which I also used in my other tutorial. A cosine based color function. It's called palette. Or get pal. Gets a value x and returns a vec3 for a RGB color. And if you haven't watched my other tutorial, I'm gonna briefly explain what I'm gonna do here. I use a cosine on a 3D vector. We want to normalize it to 0.1, so I'm going to use the n cos, and also have it going full round, so 2 pi times x, so we're gonna we want to iterate the value we get in over the whole circle, or the whole period of the cosine function, and offset the different channels slightly, so we get some color variation. Plus 2.3 here. This will do two things. It will create the offset and also change the value to a vec3. So it will implicitly cast the whole input to a vec3, so we get a cosine function for each element of the vector. So basically this will return a color. And just to demonstrate how it looks like, we can use it here. Get oops, I have an error. Still not. Okay, and cos doesn't exist for vec3, so I'm gonna use cos and normalize it to 0.5 to the 0,1 range. Okay, so now we get our color palette, and it's wrapping around because it's a sine. So if you use time here, you can see it's going like this. You can change also the values here to something like this. Okay, let's go with that. And now we want to colorize our particles along the path. So let's use this is the brightness value for the ring, and then create the color value with our palette function, and give it a path and also multiply it by the brightness value. So this should give color path. This looks super cool already, even without the feedback. Let's give it a little bit more feedback, because that's the thing, if you have an error, it's going to reset all the variables, all the controls to the default version, so you have to reset them. You can also go here on the right hand side to this palette icon and create some presets. So I'm going to do this. Feedback preset. Yeah, this looks already pretty cool. Have it even more feedback. Yeah, something like this. Yeah, I think have the second value bigger than the first one. It's doing the trick. Cool. So yeah, this is already almost the final effect. There's just a few things we can do. First of all, we can also use the mirror here to see, gives a nice symmetrical effect. And then of course we can add tons of more parameters to control all the different kind of things, which I won't do now. You can always go to my Patreon page and grab the final version where I added all the parameters for all different controls to have it a little bit more customizable. But you can also create them yourself, just add parameters and then use them as you want. You can have the freedom, play around with it. One thing I want to do still is, first of all, you see that some of the particles are stationary, so they don't move. It's because the random value is going from 0 to 1. So if you have a zero value for the speed of our movement, then they won't move. So we're going to change that by having it scale to a specific range. Let's say 0.1 to 1. Okay. There's still some particles not moving. Okay, I think I figured it out. The direction is also a directional speed, basically, so this also has to start with a small number. So we're gonna give it a point at 0.05. And of course you can always also play with the seed value to change this. Also make a parameter maybe for the radius. Call it radius mod. Make it a knob. Change this modular mod. Yeah, let's add it here first, radius mod. I have to save it. And also change our hash value. To a different range. With a bit more variance. Let's see how this looks like. Can change the max radius and the radius mod. Yeah, you can change how fast the circles are changing the size. Okay, you can go on with this indefinitely. So one thing I want to do before wrapping this up is to add some audio reactivity to the scene. If you have not done this before in Synesthesia, you can check out the Synesthesia audio uniforms page in the documentation. There you will find a description of all the different uniforms that Synesthesia is providing. So these are variables that are defined within the Synesthesia code, the GLSL code, that then will contain some audio information that you can use to animate your scene. I'm mostly going to use the hits and time-based values. So a hit is a value in the 0 to 1 range that has a relatively sharp attack, so it's increasing every time a specific frequency band is hitting. So if you have a high hit, this is creating a spiking motion or a bass drum hitting. And then we also have time-based values, which are continuous, like a time uniform, so they are increasing from 0 to infinity, but with the difference that they are kind of driven by the activity in the music. So for example, if you have a syn bass time, this is pushed forward every time bass is hitting. So this is pretty cool to use for path-like animations. So let's go back to our code editor here and also turn on some music. So we have some speed to work with. So yeah, first let's use the Syn base time to move the particles forward along the path. And we already have our speed, which is our usual time, and we're just gonna add our audio time to this. It's Syn_base time. So now you will see what this is doing. So it's pushing forward every time the bass is hitting. It looks cool, but it's of course way too fast for what I have in mind here. So we're gonna scale this down by multiplying it with a smaller number. And then we have something which is cool. Another thing we can do is to modulate the thickness of the ring of these circles with a hit value. So we already have the thickness here, and if we subtract, or we can just also add it here. Use the Syn. Let's use the hi-hat. Yeah, this is way too much. Multiplied by also 0.1 maybe. Yeah, this is something cool. And gonna turn on the mirror here, so we have some symmetry, which I think is cool. Another thing we can do also to create some more variety in the overall look of the scene is to add some distortion. So we can distort our coordinate system with a sine function. Our coordinate value is the vector p, so we're gonna add a sine to it and modulate it by itself, so but in a reverse order. So we want to modulate the x coordinate with the y and the y with the x, so we're gonna reverse it and also increase the frequency by multiplying it with a bigger number, and decrease the amplitude, so we just want to have it affected very small by 0.1. And yeah, this looks already pretty cool. Note that this is increasing the distortion every time in the loop. You can also pull this out, do this before. It's gonna be way smaller, so we have to probably increase the number. But yeah, I think I really like it in the loop. It's gonna get this cool square-like effect. So I'm gonna keep it in here. Of course, we can also create a parameter to control this. So I'm gonna add a parameter distort here. The parameter editor, add it to the base group, give it a knob and save it. Of course, we have to apply it here also. Distort. So this is distorting the amplitude. Let's reset the scene here quickly. Okay, so now we can increase the distortion. I think this looks pretty cool. So this was my tutorial. Thanks a lot for joining. I will provide a download link for the whole scene on my Patreon page. This will contain additional controls and additional audio reactivity and also different color variations and all that stuff. So please go there and check it out. Would love to have you joining. See you next time.